Mars is our neighboring planet. That's how it's usually described. But imagine this for a second. You're on a spacecraft halfway to Mars. Something goes wrong. You send a message back to Earth asking for help, and the reply arrives 23 minutes later. Not because the engineers are slow, not because the radio is weak, but because Mars is that far away. And suddenly, the idea that Mars is our neighbor starts to feel a little misleading. Because the real challenge of reaching Mars isn't just distance, it's what that distance does to time, communication, and the human experience of space. At first glance, Mars doesn't seem that far away. In the solar system diagrams we all grew up with, it's just the next planet out from Earth. But those diagrams hide something important. Planets aren't parked in place, they're moving. Earth races around the Sun once every 365 days. Mars moves slower, taking about 687 days to complete its orbit. So the distance between the two planets is constantly changing. Sometimes Earth and Mars are on the same side of the Sunday. At those moments, they can come within roughly 55 million kilometers of each other. But when they're on opposite sides of their orbits, the distance can stretch to more than 400 million kilometers. That's more than 7 times farther. So Mars isn't just far, it's a moving target. And that creates the first trap of Mars missions. You can't just launch whenever you want. Space agencies wait for specific moments called launch windows, when the geometry of the solar system lines up just right. These windows open only about every 26 months. Miss one, and the next chance to leave might be over 2 years away. Which means Mars missions aren't scheduled around convenience. They're scheduled around celestial timing. But even when the timing is perfect, there's another problem. The fastest route to Mars is not the one we can actually afford to take. To save fuel, spacecraft usually follow a trajectory called a Hohmann transfer orbit. Instead of blasting straight toward Mars, the spacecraft enters a long, stretched ellipse around the Sunday. At one end of that ellipse is Earth's orbit. At the other, Mars will eventually arrive. It's less like flying directly to a destination, and more like throwing a spacecraft to where a planet will be months in the future. This path uses the least fuel, but it also means the trip takes time, a lot of it. Even our most advanced missions today still need months to reach Mars. NASA's Perseverance rover, for example, launched in July 2020. It didn't land on Mars until February 2021. That's roughly 7 months traveling through deep space. And that was just a robotic rover. A human mission would likely be similar, somewhere in the range of 6 to 9 months just to get there. So already Mars is starting to look less like a quick trip, and more like a long corridor through space. But here's the moment where the picture changes again. Because the most surprising thing about Mars travel isn't the length of the journey. It's what happens to Earth during that journey. As a spacecraft moves farther away, radio signals take longer to travel. At the Moon, the delay is barely noticeable, about 1.3 seconds. But Mars is much farther away. During parts of a Mars mission, a radio signal can take up to 23 minutes to travel one way between Mars and Earth. That means a question asked from Mars could take nearly 45 minutes to get a reply. Imagine that during a critical moment. A system fails. A decision has to be made. Mission control can't just guide the crew in real time, because by the time Earth answers, the situation may already be over. At Mars distances, astronauts can't rely on Earth the way every space mission before them has. Mars is the first place where Earth starts to feel slow, and sometimes Earth disappears completely. When Mars moves behind the Sun from our point of view, solar radiation can interfere with radio signals. During these periods, called solar conjunction, communication between Earth and Mars can be disrupted or cut off entirely, for days, sometimes even weeks, which means the crew on a Mars mission must be prepared to operate completely on their own. No live guidance, no immediate help, just the spacecraft, the crew, and the long stretch of space between planets. And the challenges don't stop there. NASA describes 5 major hazards of human spaceflight beyond Earth orbit: radiation, isolation and confinement, distance from Earth, reduced gravity, and living in a hostile, closed environment. A full Mars mission traveling there, staying for exploration, and returning to Earth could take around 3 years. 3 years inside a confined spacecraft and Martian habitat. 3 years exposed to cosmic radiation. 3 years operating far beyond the reach of immediate help. So when we talk about going to Mars, we're not just talking about building a bigger rocket. We're talking about navigating a journey where distance affects everything: communication, autonomy, biology, psychology. And this is why Mars is such a powerful milestone in human exploration. Because Mars is not just another destination, It's the first place humans may go, where Earth stops feeling nearby. The planet will still be visible in the sky. Mission control will still be listening. But the relationship changes. Messages arrive late. Help arrives even later. And for long stretches of the journey, there is nothing between the spacecraft and the stars except time. Which means Mars teaches us something new about distance. Not all distance is measured in kilometers. Some distance is measured in minutes of silence, some in months of travel, and some in how long humans can live in a place where Earth is still home, but no longer right there. Mars may be our neighboring planet, but reaching it means entering the first frontier where distance becomes human.